Welcome to this webinar on optimized traffic data to make your cities safer and more efficient. My name is Joris Breton. I joined Teledyne FLIR in 2008, and in full disclosure, and to be complete, the company then had a different name and changed quite a few times from owner and from name until we are now currently Teledyne FLIR, and more specific, Teledyne FLIR ITS. I've always been involved with training, so explaining to you, to our customers, what products we have, how we can use them, and from time to time, organizing webinars such as this. So welcome in this webinar, today's webinar for about 45 minutes, and I'll be your host. I'm joined in this webinar by Kelly Hoston. She is our regional marketing manager, and she is monitoring the chat and question box of this webinar. So if you have questions, if you have remarks, please drop them in the question box, in the chat box. We come to the questions at the end for sure. And she will also be the voice behind the poll results. So welcome, Kelly.
Thank you, Joris. Welcome, everybody.
And again, a special welcome to you for this webinar on optimized traffic data to make your cities safe and more efficient. I do realize that I dropped a few other names beside my own name and Kelly's name in this introduction, Teledyne FLIR, for instance, and this requires a little bit of an explanation. First, let's start with Teledyne. Teledyne, or better, Teledyne Technologies Incorporated, is an American conglomerate. And Teledyne provides enabling technologies mainly for industrial growth markets. To be simplified said, they create key technology, and one of the key technologies is sensors. If you go back to your time, school time, your physics time, maybe you remember the electromagnetic spectrum, going from the gamma waves on one end to the radio waves on the other end of that spectrum. Well, in fact, Teledyne has for each bandwidth, for each region in that frequency, they have any type of sensor. And in fact, that's why they bought in 2021 FLIR, because with that buy, they completed their Teledyne portfolio. They strengthened, in fact, the thermal frequency range. Teledyne, or better, FLIR, has been for decades, since the 1970s in the last century, been a specialist, in the design and production of thermal imaging cameras and sensors. And then we come to the final part, to the ITS part in Teledyne FLIR ITS. And this refers to the department which offers already for over more than 30 years intelligent transportation systems. These systems are technologies which are based on video image processing using advanced technology, advanced analytics. And we help customers to create in the field of traffic a smarter city. Or when we look to highways, bridges, and tunnels, we have technologies will help them to detect very fast incidents on those roads, but also to handle those in a very efficient way. In other words, ITS focus on making your traffic safer and smoother. And that's the nice thing about ITS, or our part. We're talking about video image processing. So we have video, and as you know, the saying goes, an image says more than 1,000 words. So imagine a video. Therefore, I have a few videos that will show you and demonstrate you very fast what errors and what I'm meaning with our ITS solutions. The first one that I want to show you is a video taken at an intersection. where we detect with this sensor, with this visual sensor, we detect vehicles approaching or at the stop bar. And that information we pass on to the traffic signal controller in a way that it can be used to change the traffic lights dynamically based on the real traffic. So for the moment, these need to stop. The other direction gets priority, but the controller has that information now, and it can be used to change in a few seconds. Voila, there we have it already. Change it back to green. Another example is this one here, where we have an incident happening on the highway. And within a few seconds, we're talking 10, 12 seconds, you will notice there's going to be a square appearing, meaning we have detected that incident. That goes to the traffic management team, and they can assess the situation and of course take immediate action in a sense that, okay, probably the firefighters need to be there or maybe close the road, depending on the severity of the incident. That's an example on a highway. Another example to show you with a thermal camera inside a tunnel. And here the main focus of that camera was to detect if there's a fire in the tunnel. And you will see this is going to happen. Notice the time also. So about 10 to 6 in the morning, we have a car stopping. We will have an incident alarm popping up. Right now, we will have the stopped vehicle and the fire alarm going on. This goes again to the traffic management team. They assess the situation, and in this case, they acted really quickly, closed down the tunnel, alarmed the firefighters, and in about 15 minutes later, 18 minutes later, they were there already pulling out a lot of stuff just to prepare and make ready for extinguishing the fire. And as you will see, in total, it took 1 hour since the incident, and the tunnel is already made available for the customers, for the citizens of that particular city. These are a few examples. Now, before I go to the topic of today, I would like to know, I have a small poll for you. So which traffic data interests you the most? Are you interested in only just knowing the number of vehicles, or you say, nah, to be honest, I would like to have a little bit more, like vehicle classifications, the speed, the position, the distance to the previous one, to the next one. In fact, detailed traffic data from where my sensor is. Or you say, no, to be honest, I'm more interested in the data for my whole city. So please, Kelly, can you start the poll? And I give you 30 seconds to answer to these 3 questions, and then we will see what the results are.
Yes, so the results are currently already coming in.
Yes, oh, beautiful.
Just waiting for, yes. So people are eagerly replying to the poll.
Nice.
And I'm going to close the poll now.
Yep.
The results of today's poll, 10% went for the number of vehicles, 55% opted for the number of vehicles, vehicle class, speed, position, etc., and 35% opted for detailed traffic data for the whole city.
Okay, yeah. So number 2 and 3 are really the top ones in this poll. Thank you very much for that.
You're welcome.
So the focus of today is optimized traffic data. So by participating in this webinar, you're showing interest in how to make the traffic in your city going smoother and more safer, and how traffic data can play a role in that. Maybe you already have sources out there that can pull in that data, or maybe you're looking for different data sources, or maybe you're looking for resources, how you can combine or optimize the data you already have. Well, this webinar is really about that. This webinar is really on how you can tap in into, for instance, the Teledyne FLIR ITS solutions to collect that data and how we can collect that data, but also how we can, or how you can optimize the data you already have, that the data that's already out there, how you can optimize it first on the level of the position where the camera, where your sensor is, but secondly also on the level of a larger area, the city, a region within your city, a larger area, how we can do that. Because if we look to a city, well, within a city on a transportation level, you have different traffic stakeholders. We have motorists, we have cyclists, we have pedestrians. And each of them, they claim a portion of the public space. And each of them, they want to reach as fast as possible and of course, as safe as possible, their end destination. The problem is, from time to time, there will be some conflict areas. And we will need some technologies to make that happen as smooth as possible. Simple technologies as assuring that each of them has a nice road, or more complex technologies like with dynamic traffic signal controls, that we have traffic lights, but also that it's made, for instance, dynamically. So we need solutions. ITS is there to help on some solutions. But then, not only these solutions, how we can get more out of these solutions that we can improve on our city, because our city, that's not something static, that's evolving by day, by year, by decade. So it's changing, and you want to know how it's changing. Is there information out there that you can use to predict the change, to be ahead of the change, to make sure that what is coming towards you, you're ready for that? Well, on that, we would like to help with our solutions on data. And what are these solutions? How is the basic architecture, the basic idea behind the video analytics? Well, it starts all with a camera. And that camera can be a visual camera or can be a thermal camera. Now, this camera is monitoring your road, your intersection, or maybe just a road because you want to detect where a pedestrian is walking or cyclist is driving, you want to monitor. These cameras are detecting, are processing, are analyzing, and then at a certain moment, they detect what they need to detect. For instance, a car. That will be, simply said, a contact closure that goes to an interface which connects to your traffic controller, and that traffic light controller gets that as an input and will adjust its settings to the information it gets from all the sensors out there. But that's not the only way. That's the most obvious, common, known way. But there's already a possibility today with the latest version of certain traffic signal controllers, is that they can listen, they can register, subscribe to XML. And XML will have much more information, much more data in it than just yes or no, there is a vehicle out there. So you can already tap into that. But if your controller can tap into that, well, yeah, you could, if you want to, store that data on your own server. If you have a server somewhere, everything is connected to a network, well, why don't you send that data to your server? Then it's for you. And depending on the size of your server, you have that data. But why not put it, let it collect on a cloud server? What would be the big advantage? And then we will go later on a little bit more in detail. But if we look at the difference between storing it on your own server, well, it's data, pure data. You will still need some tools to interpret the data, to make it available, easy available for a lot of people. The cloud solution, well, we offer it already for you in a nice way, and it will be easy accessible. And let's now check all three of these data sources you already have. So let's take first to the one out there, a traffic a sensor that's out there for traffic signal control, and to dynamically change the light based on the vehicles that are approaching the stop bar. So here you see a car driving through those detection zones. You see them changing color. That means an output is triggered to the traffic signal controller. And that traffic signal controller can now use that. Okay, I'm going to change from red to green, or from green to red. The next one you will see in a bit, there's going to be some trucks driving through the left turn lane. Well, that information goes to the traffic signal controller. He knows, oh, trucks are approaching. Well, I will extend my green time. That's what's going to happen right now. That is now by contact closure, but if you want to, you could have also that information going over an API. And maybe in that API, not maybe, yes, in that API, it's possible to have also the occupancy levels, how much percentage that zone was occupied and for how long. Information you could also use. Another one is where you want a little bit more information, considering different traffic stakeholders. In this case, what you see is with a thermal image, in this case, you see detection zones, smaller ones where already a car is sitting in it. So there we have an output for a car. But there is also a bigger zone. And in a sec, there is going to be a cyclist driving through that. In this case, you will have different outputs for a bike and for the cars. And there is the bike coming right now. Yes, there he or she is. Voila. Getting that information out to the traffic signal controller by dry contact, quite straightforward. Is it possible to have it also as an API? Depends on your traffic signal controller. If you're a network, you could, store that on your server, that information, showing how many cars were passing by, how many cyclists were passing by in that zone, and you would have that separate data, even occupancy, at what time, and so on. So detailed information. It's not only about pedestrians and cyclists and cars. We can also have sensors that mainly focus on pedestrians. Like here, we have an example where we detect a pedestrian, who wants to cross. Okay, the person is pushing a button, but in fact, the button doesn't do a thing. It's in fact the camera a little bit more up there that does the work. So that camera detects that person, gives an output to the traffic signal controller saying, okay, somebody is waiting here. Please take that into account. Make sure, let's check if we can give green for the person, red for the cars. Let's check, let's wait. That person still has to wait because still plenty of cars going around. But at a certain moment, you will notice there's going to be green for that person. And again, here with outputs, but if you want to, you could loosen it to an API. And the person gets green. The nice thing here about using that type of sensor is that you could know how many people are waiting. That information you get through the API. But also here, if the person is pushing the button, is in the location, but runs away, then we could cancel the call. And you could also have that data in there. Probably not, well, maybe also with your outputs, but for sure also in your API. The next one is not as traffic signal control, but mainly a focus on vulnerable road user detection here to detect, for instance, somebody crossing, where the moment somebody is entering or approaching the crossing or crossing on the crossing itself, what happens? You see these flashing beacons going on, saying, oh, be careful, somebody else out there. Most cases, it will be just that contact going to the traffic lights. But if it's on a network, you could use that information, that API, store it, have data of what's happening out there during the day. And the size of your server will tell you how long you will be able to keep that data, to have historical information. But I noticed that you're also looking at, rather have really detailed data. Now it's data that is part of another application. And we see the vehicle, but we can also have occupancy account to it. But sometimes you say, no, I really want data. I really want to know, and I will start the first one. Like here in Singapore, what we did here was, no, they really want to know on that artillery road, how many cars were passing by, what classifications, how many, from which classes were passing by, what was their speed, their average speed, what was the difference, the distance between the one before them, etc. All this data you're collecting. Then that will be really, tapping into what the camera kept or sending it towards your server. Not only here it's on a road which is, next to a road, but it's also possible to collect some of that data at an intersection. So here we're looking at the stop bar. This is possible in this example to know how many cars are stopping there, how many trucks are there, what was the speed when they're driving through it, all that kind of data. It's also possible to collect out there. Yeah. Then I have a new question in my poll, and that would be, if you were looking for an application, or if you would go for an application from FLIR ITS, which would you use it for? Would you mostly use it for traffic signal control, to detect vulnerable road users, traffic data, or if possible, all of the above? So let's start a new poll on that.
So the poll is launched, 47% already voted. We're approaching 60% of the audience. Yes, they're very, very active.
Great, thank you.
We're approaching 70% of active watchers. That's good. All right. I think it's time to close the poll.
Yes.
We had 32% opting for traffic signal control, 5% vulnerable road users, 21% traffic data, and 42% mentioned all above.
Okay. Yeah. Okay. Thank you very much.
Welcome.
Good to know. Yeah. Okay. These are now our sensors. But of course, we're talking here about how can we optimize that. And currently, the data you can get out of it through the iContacts API. But is it possible to optimize it? Yes, it's possible to optimize it. And in fact, there's a game changer in that area. It's called AI, artificial intelligence. And I do know it's now a buzzword, but bear with me. The buzz is more, it's more than a buzz when it comes to traffic. Until recently, so all the sensors that you saw currently, the images from, how did this work? Well, it was based on its video image processing, but based on video analysis. So what's happening inside the camera? So we have a camera monitoring the road, and the algorithm there will digitize the complete image, digitize it in an 8-bit data stream. So we know for each pixel, its value between 0 or 255. Or in other words, if it's black or white, or somewhere in between, a gray value. And it's with that information that we're going to work, because our algorithms are going to look for contrast. We're not going to do that with a complete image. No, what are we going to do is we're going to draw what we call a detection zone. And the moment that detection zone is active, we're mainly going to focus on that particular area. Sensors are going to pick in and are going to check, okay, what is the current value? And the moment a car gets into it, stops in there, wow, there will be a difference between the previous value, a new value. And the bigger the contrast, the more we like it, the better it is for us. And that's the way how we detect pedestrians. That's the way how we detect cyclists. That's the way how we detect cars, know their speed, and so on. That's the basic principle behind it. But now there is AI. And AI, artificial intelligence, the way it happens with these new sensors, with these new processors on thermal or on visual, is there. The visual image processing is like mimicking how our human brain works. Simplifying, how did we learn what a car is? Well, when we were young, people were telling us, that's a car, that's a car, that's a car, that's a car. And the more we saw these images, yeah, after a while, we were able to say, when we saw such an object with these wheels and with these headlights, oh, that's a car. I do know some of us were a little bit early. After a few months, we could say that's a Porsche or a Ferrari. But anyway, that's the way it happened. And that's the same thing how these sensors are. What is happening? We are going to feed these sensors with a lot of images of our stakeholders, unique images due to our history in that field. We're going to feed them. And these algorithms, this artificial intelligence, what's going to happen is it learned from that, it knows from that what a car is, what a bicycle is, what a pedestrian is, how it looks like, what a truck is, what a van is. So in the end, 100% detection, still a big problem, but 99% of the case we can say it's a car, and maybe 1% we will say it's going to be a van or a truck. But what is now that big advantage towards it? Well, if you look at it, if you look at the image and you see here an image of an intersection, the moment that an object, a stakeholder, enters the scene, comes into the view, or even moves within the view, the AI will recognize it as a stakeholder. And the closer it gets to the camera, it will really give it an identification. And really at the end, it will say, okay, it's a stakeholder. I have no idea yet what it is. Maybe a car, maybe a bus, I have no idea. But when it gets closer, oh no, it's a pedestrian. Oh no, it's a bicycle. Oh no, it's a motorcycle. Oh no, it's a car. Oh no, it's a van. And that is what's happening. So with the AI, the system has what we call situational awareness. It's aware what is happening inside. And it detects the moment such an object moves within the scene. And this has now an impact on two levels, on optimization on two levels. The first level on optimization is on vulnerable road users, on our pedestrians, on our bicyclists, and our cyclists and our pedestrians out there. As you can see here in that image, and here it's labeled with the speed next to it. We detect them. We know that that's a pedestrian. Okay, with the video analytics, we were also able to do that. Otherwise, I couldn't show you these examples. But there was a big but behind that to make sure that we had them. It was always a question about position your camera in a correct way, the right angle. There were some guidelines, strict guidelines to follow. If you didn't follow them to the T, it could result as not that high percentage of detection. Here, in this case, the moment an object enters, based on the huge database it learned from, it will know, okay, we're talking about a bike, a pedestrian, and also allowing a difference between a bike and a pedestrian. Also a difference between a motorbike and a bike. All now possible, all more and more details. So that's the first level of optimization that we have with that AI. But there's also a second one. And that I will show you with the next two clips, with a visual one and a thermal one. And when you look at the image, you see that on top of the cars, next to the cars, you see these labels. With the visual one, we only have the name of it, but with the thermal one, here I also added the speed. What's not in there is the position. Because what's happening? The moment a stakeholder gets into the view of an AI, we are going to label it, knowing in the end it will be a very good recognition, but we will know it's anyway a car. It will give it, we know the speed, but also every second it's in the view, in fact, every millisecond it's in the view, we will know its position. We will know it until it leaves the view. We will know it. And that results, in fact, that we can create, if we save all that data, into a duplicate of where the camera is looking at. We have the digital data, we have the digital duplicate of what the camera is looking at. You could say you have a digital twin of what you now see visually, of all the traffic that's passing by. Okay, we don't have a digital print of the trees out there, but of the vehicle, of the traffic we have. And that's what we are looking for. So with contact closures, so if we have a camera out there, and in the beginning, we have detection, contact closure. You have the API, the possibility of also tapping into the API. Now with our AI, but also it's a bit possible with the API, you have a good image of what's happening there. But with the AI, you really have a digital twin, digital duplicate of what the camera is looking at. And imagine now that at your intersection, you have not one sensor, but you have 4 sensors. Well, combining that, well, you have a digital twin of your intersection. And let's now imagine that we don't have one intersection, but we have in our city multiple intersections, that you could group, put all that together in one place, and then look at it from that place. And that is what happened in Acyclica. So what you see here on the image, and I will start, I made a recording out of it. Here, and this is an example of the city of Oldenburg. So here, the city of Oldenburg, we have these different sensors. Some you might see there's a number next to it. That means that there are so many sensors on that location. And we're only going to show you the location and the number of sensors next to it. And they are collecting on that spot. They do stuff. They have just a normal application as, for instance, traffic signal control, but they have also collecting data. Once or large or not that large. And we are going to collect it in here, and which allows us to look at it. And here I will start and show you what is possible within that application. So I can zoom into it and say, look, that in fact, that camera belongs to a certain route. So I can get that information out of it. Know that this location has 2 sensors on there, and these sensors are collecting data. And if I want to, I can also have a peek on, oh, they're looking at that. So 2 thermal sensors, and you notice we see the detection zones, what they're looking at. So these are not yet artificial AI sensors. And for instance, I want to know in the last few days, how many cars passed by. And I can go for a time interval. So here I will select not 5 minutes, but 1 hour. And I specify the date. Let's say that I do it yesterday, no, the day before. Yeah, and let's go that I will do that until today. Then I can select the sensors. Currently, I can take all the sensors, sorry, not, all the sensors, both sensors. But I could also say no, on that sensor, I only want that zone, the information of that zone, and then I will have that information. And so I have now the information of all these drones represented here with a color. If I go to a certain point, I will notice on the left, on the right top corner, how many vehicles passed by on that particular spot. I can zoom in on it. taking closer detail, zoom in on a horizontal way over time, or really diving into it, which I will going to show you next. Voilà, and I see it there. But another advantage is when I'm connected to that overview, the nice thing is I will see based on the colors of the roads of the camera itself, yeah, I can give their warnings on that. So currently all is green, that means normal. When it's blue, that means I selected because I'm playing with it, but it can also have different colors depending on what you set up, and each color can have a particular alarm meaning towards you. Also, the routes you see currently all green, you know, all Google Maps and maybe when you look if there is a queue building up, yeah, you will see the colors. The nice thing also about this Cyclica tool, currently it's taking most of the data out of the FLIR ITS solutions, but you could also integrate it with Google data, with TomTom data, with maybe from other sources I don't have right on the tip of my tongue, but you can integrate it. So really enriching the data for your city, allowing you to get a lot of information that you can use. And going forward to it, thinking about it, what triggers you the most to know more about it? Are you more interested in know all the output solutions, or if they public API, I would like to know what's about that. The cloud, I would like to know more about the cloud, or again, all about all the above.
People are voting very quickly. We're already at 50%.
Right.
All right, 60% of the people have voted.
Nice.
Yeah, nice to have such an active crowd.
Yep.
All right, we're approaching the 30 seconds, so I'm going to close the poll and share the results with you. All right, so we have 26% that voted for output solutions, 21% for public API, 12% for the cloud as Cyclica, and 41% for all of the above.
Nice, nice, very, very good. Yeah. So in fact, to get the data out of there, so there's, yeah, you have the output, that's a simple one. We have the API that you can tap into it, and you have the Cyclica cloud. So these are the three methods you can get data out of your sensor. The question was here, how can we optimize that? Well, optimizing in a way that you have a sensor out there. Optimization currently at the spot itself is switching towards artificial intelligence, using this type of sensor due to the fact that it has this situational awareness. The moment that an object enters, moves within the scene, we will tag it. We know exactly where it is, at what speed, because we know its position, where it's heading towards. We have all that data, and we can make a duplicate out of it. So that artificial intelligence, that's really optimization on the spot itself. And you can tap on that optimized data. Okay, contact closure will not get that much more out of it, but for sure your API will be much richer than an API with normal video analytics. Will be good, but will be much better, of course. Then we have also the optimization that can happen on a higher level, on a second level, is okay, through the API, I can store it on my servers. You have that data, but to get it turned into information, yeah, you will need to have some tools, or spend money or spend time to make the tools to get the information you want out of that collected data. Or you could say, no, all my sensors are anyway on a network. I will send all that data to our cloud servers. And that gives me immediately a really nice tool with a easy to read GUI with all the information at my fingertips. And I can look in real time on what's happening out there, but I can also dive into, connect to a sensor, what's happening. I see it live, what's happening out there, but I can also dive into the historical data that has been stored on my servers and make a comparison. Say, what's happening here? And that's the nice thing about AI, and that's the nice thing about the cloud solution. That's really, we think, as a method to optimize your traffic data, to get better insights into your city traffic, and that insight, that information will allow you to improve your city traffic. Learn how you can make at certain places things go smoother. Find out where the bottlenecks are, because you all put that together on one place. And with that note, I end my presentation. So thank you